When the music industry transitioned from tape and vinyl records to iPods and CDs, we had to convert a huge volume of analog data, that's music, into digital data for storage, and then back to analog data so you could listen to your music. They invented a chip called the DSP, or digital signal processor. This is extremely good at extremely fast conversion rates between analog to digital and back to analog. And since it's a consumer product, they built them by the million. This dropped the price. Well, in industry, we took this DSP technology and applied it to our problems in industry. Anytime you have an analog output with an infinite variable output, you need some kind of A to D conversion. And the DSP technology has now allowed us to get down into the low microsecond update rates. This is a perfect example of how consumer goods and consumer technology are supplied to industry. It's allowed the robots to work faster and more efficiently than they ever could before. Same thing could be said of Ethernet. On the internet, we need to communicate quickly and efficiently. And to do that, they've invented Ethernet technology. And what you'll find inside advanced control panels now is rather than a bunch of wires, you'll have Ethernet cables. So we're talking between our controller, our outputs, and our motor drives with Ethernet. Two examples of where consumer technology drove the price of the chips down to a point where we could use them in industry, and it makes more robots much more efficient. Improvements in sensor systems are driving robot technology. The sense that you use the most every day is vision. In the 80s, we had 2D vision, but it required a huge amount of processor speed. Well, now we have higher processor speeds, and we've gone to 3D vision. Once a robot has three-dimensional vision, now we can determine where the part is, what the orientation is, and what we need to do to the part. These sensor technologies are driving robots at a miraculous pace. Without vision, a robot's blind. It has to assume that it knows where the parts are. And in the old days, that's all we could do. We had to position the parts very, very accurately and then weld them, grind them, paint them, drill them, whatever. But that's no longer necessary. The robot can now sense the position and the orientation of the part and adapt to it immediately and compensate for any of these variations, much like a human being would do. One extreme example for an application of 3D vision would be self-driving cars. Very dynamic environment, things are changing on the fly. You have to adapt to these changes and react to them. You can't violate the three laws of robotics. So the early self-driving cars were simply line-following devices. But now with 3D vision, we're able to detect when someone jumps in front of a car, and the program can avoid that human being. One of the big drivers in these advances in technology is processor speed and memory. I can remember the 64K memory limitations and 4 megahertz processor speeds. These are a thing of the past. With higher processor speed, we can do a lot more in less time. A good example of 3D vision using this processor speed in industry is we no longer have to select a program. The robot can identify the part using 3D vision, can identify where the part is, and then select from a catalog of programs to perform the desired operation on that part automatically. So you never select the wrong program, automatically comes up and runs the part. With these improvements in technology and the onshoring trend in manufacturing, I expect to see a renaissance in America in manufacturing. After World War II, much of the power and stature of the US and the world was based upon our manufacturing capability. We've done it before, we can do it again.